Just before we start, I think we have a mixture of expertise here. How many people have written a macro before with syntax rules? Syntax case? Ever used syntax local value? All right, we can stop there, I think. Okay. So we'll start out kind of slow since you've all done syntax rules before, but you'll just have to let me know how fast.
Are there people in here who have not used syntax rules?
Okay, good. So what we're going to do as an example, we're going to build a language. And it's a language that lets you do stuff like this. It's a language inspired by Scratch. So I bet everyone here knows Scratch as well. In this language, we're going to have the same evaluation model as Scratch, the same notion of sprites and the kind of things that sprites do. We won't have the graphical syntax here. That would be like another 2 hours that we would have to do. So, but if you've seen Scratch before, you know you've got like the cat over there as the current sprite. And you can do things like move 10 steps. And if I double click it, then the cat moves 10 pixels over. And you can do things like a forever loop, which will make the cat continue to take 10 steps until it goes too far. I could pull it back over. And there's a notion of direction, so you can have the cat turn all the time, and now the cat's going in a circle. Okay. And then you can do that, and at the same time you can do some other things, like when the space key is pressed, then I'll have the cat say hello. Okay. So now if I click the space key, then the cat says hello, and that just means put a little balloon. Okay. So the evaluation model here is you've got a sprite, it has some state, and you have various operations that modify that state, and you have loops, and you have a bunch of processes running, sort of a bunch of little tasks that run all concurrently. And yeah, it's stateful, and yes, it's easy to get race conditions and all of that, but that's not what we're worried about. We're just going to make a language that's like that. So here is a simple version of this text language that we're aiming for. And you can see I've called it Scratchy. And this line of dashes, that's not a comment, that is the beginning of a sprite declaration. And I'm calling the sprite fish. And then I say image is, and then I put the image for the fish. And then this is do starts a task. This is the forever loop. I should have made this wait instead of sleep. That would have been more Scratch-like. But that just means wait for 2/100ths of a second, then move forward to, then turn a random amount. So when I run this program, we get a fish that just sort of drifts to the right, but walking a little bit randomly. More interesting things you can do with Scratch. Here's another one. This has got a duck that starts at a particular place. This is, the duck is going to move around. When I push the up key, it'll move up in the Y direction by 10 and turn to 0, and that's 0 is north in Scratch. Down goes down by 10 and turns around. I got my fish again. My fish is going to do the same sort of random run around, but now also I have an operator touches, so I can say as long as it's touching the aquarium, my score gets greater. I get points for the fish staying in the aquarium, and when the fish touches the duck, then it's going to stop talking about the score and turn and wait for the duck to stop touching it. So the goal of this game is to keep the fish in the aquarium by herding it with the duck. So see, now I got the fish back in there. My score is all the way up to 250. See, and it's out of the aquarium. And then he moves around. Okay. So that's an example, and this is going to be our running example. The little shepherd the fish with the duck game.
Just to get going quickly and not avoid listening to you, can you tell me when it says standard name resolver collection not found for Scratchy, I just downloaded it.
Okay,
I want
great.
to get that in quick without losing track of
Okay, good. So if you were trying to play along, then you went to this web page, and on that web page here, there are a couple of ways you can get. If you get it through GitHub or through a zip, then what you'll need to do is go to your directory and do racco link that directory. So go to the parent of the directory and do racket link Scratchy. And then after you do that, you won't get that error message, I think.
Should we start with pre-Scratchy or Scratchy?
Start with Scratchy for now. And then pre-Scratchy, we'll just call it pre-Scratchy so it doesn't collide. Right. If you just download the PLT file, then it installs, and you install it in the usual way. That sets up the Scratchy collection. Right? And then this other archive, the pre-Scratchy, that is this code, but with all the solutions stripped out. Right? There are lots of dots that we're going to fill in interactively. So the intent is mostly that you look at this, but set that up so that we can run Scratchy programs at the beginning. Is it working?
Probably.
Probably, okay. Let's see.
Can you write on the command in Blackboard?
Yeah. So after you get it, assuming you're in the directory that has the Scratchy impact. Okay. If you don't want to do this, just use the .plt file instead. And when you install it through Dr. Racket, then you'll get Scratchy. So that's a 4. Okay. So you get the idea of the kind of language you're trying to write. We're not going to talk so much about building the actual graphical part. So we're going to take as given a piece that comes with it. So Scratchy comes with this textual language, which, here's more example in the grammar. Okay. But we're going to take as given the runtime part, which is really just 2 parts. Sprite class that gets instantiated, and a run function that takes a list of sprites and then runs the world. So here in fish1, now, fish1 is in Scratchy and pre-Scratchy. This is where I'm using the runtime, and this is our running example. This is code that we do need to understand, that we're going to turn this code gradually into this code. Right. So gradually build up our language, not that code, this code, right, where we have the duck and the fish and so on. So how many people can read this code right offhand? Okay, so let's go through it a little bit. So here I'm defining the duck sprite by instantiating the sprite class. And the sprite class takes a bunch of initialization arguments. It takes an image argument, where I'm giving it duck image. And I've set up this images file just to make it convenient instead of cutting and pasting images all the time. I've got duck image, fish image, and aquarium image. Okay, so we can use those names. So here I'm using the name duck image, okay, to get the duck image. This duck is starting at Y position 100. So in Scratch, it's the mathematical usual orientation. Positive Y goes up, negative Y goes down. Right? So this is saying, and it by default starts in the middle, so this is saying up above the middle. And then I've got key callback here. This is an initialization argument for the sprite class that takes a function that wants whether the key was pressed as opposed to released and what the key name was. And so when the key is pressed, then I dispatch on what kind of key was pushed. And if it's up, then I tell the duck to move up by 10 pixels. So the send is how you call a method on the duck sprite, which is an object. And so after I move 10, then I send the duck turn to 0. Okay, so you see this is much more verbose. You have to know a lot more about the Racket class system to use this. This is what we're going to turn into a DSL for sprite-like games. Any questions on this? So now how many people can read this? More? Some of you either can't read it or are unwilling to raise your hand. But any questions?
Sorry, I'm still trying to figure out where this file is. I'm like,
Okay, it's called fish1. So you should probably be looking at fish1 in pre-Scratchy.
pre-scratch.
Because those are the files we're going to look at, and eventually they'll have dots there. Any other questions to get going? Okay, so that's the duck. The fish, I'm just giving it an image and no other configurations. And the aquarium is just the blue square. So Again, nothing happening there. And then I've got the score variable. Remember, I was going to keep score as long as the fish stays in the aquarium. And this is a task that is implemented as a Racket thread. So I'm creating a thread, and when the thread starts, it runs this procedure. And the void here is just so it doesn't print the result, which is a thread. As I'm ignoring it, I'm just letting the thread go and run forever. It runs forever by running a loop here. So let loop means start a loop. That you can see I'm calling it here at the end. So that's a loop. That sleeps, tells the fish to go forward. When the fish touches the aquarium, so touches is another method we have available. Then I increment the score and I tell the fish to say the score. Meanwhile, when the fish touches the duck, then the fish stops talking, it turns around, and has an inner loop here that waits until it's not touching the duck anymore before it moves along. Right, so you can't get points by pinning down the fish with the duck. Right, you have to move off the fish and let it swim around. And then the other task here is just making the fish wiggle. It's a task that's a loop that says sleep a little bit, then make the fish a little bit bigger, sleep a little bit more, and then make the fish back the way it was. And another thing to notice here is I've used #e. Right? This is very ugly because I really want exactly 5%. I guess 5% would probably be exact anyway as a floating point number. But in other places I'm using 0.1. Oh, no, it's not. You're right. Right, it's 1/10. That's half of 1/10. Right. So I want exactly 5% because I want it to get back to the same place if I grow and shrink. I guess that's more important over here where I'm changing the size.
I noticed that in most of the loops you have some sleeps, but that inner one with where the duck is touching the fish, there's no sleep. Is that on purpose?
Yeah, because I want it here. As soon as it stops touching, I want it to keep going.
Okay, it just looks like a busy loop, that's all.
It is a busy loop. It's a bad way to write programs, and that's what happens in Scratch. Any other questions? That was a good one. Okay, so this is all just setup, right? Is anyone still trying to get the download stuff to work, or we're all set? Okay, so how can we improve on this? We could just jump completely to that other language. That would be too big a step. I'm going to suggest that the most ugly part at the moment is this void thread lambda bit here. Because that's not like the forever that I just want to write. So step number 1, we would like to just write task forever down here. So start a new task, and this particular task is going to do a forever. And then I'm using when, and I've got a while down here. So I've got forever and while and task. Those are three abstractions, 3 little language features that I want to have for this language. Okay. So how do I do that? Here I've done it by importing the task library. Let's see, why does it want to open for me? Okay. Task. Okay, that's not going to work yet, right? And that's in fact why it won't open the file for me, I guess. So if I try to run this, it's not happy with task. So let's go fix this. What goes in place of the ... So I want something where I can say forever and then some number of expressions, right? Okay, so the way we get this is, actually let me try making it a function first. What if I say forever is a function that just does the loop? Right? And then if I want to do forever printf hi, I should see hi being printed forever, right? Okay, and you all knew that this was not going to work. Why is that?
It's called by value.
Right, because this function takes an argument expression and we're giving it, we wanted this to be an expression, but of course it's a value. Okay. So by turning this into a macro instead, right, now E is just exactly this expression. Right, and it expands to the same thing as this gray part here, where we put E in place of that. So now we'll get a bunch of highs. And that's almost what we want, but we want any number of e's. And the way we get any number of e's is just putting dot, dot, dot there. Okay? So for people who haven't seen syntax rules before, define syntax rule is just a pattern-based macro that expands out. And the only thing that would be at all surprising is that you can put dot, dot, dot here, and what that means is allow any repetition of e. And then since we use e with dot, dot, dots down here, that means repeat whatever you matched, that whole sequence that you matched. So now I can print f high, and I can sleep for a second before I do it. So that just slows down the printouts now. Okay, any questions here? That was forever. What should while look like? While has a test and any number of expressions. Sound good? Okay. Can that be a function, or do we need a macro in this case? Since I want to write just while and then the expressions, I need a macro again to build this part of the language. That is a loop with all the e's. So far it looks the same as forever, so what should be different?
Test and test.
We're supposed to use the test to decide whether to keep going.
Can you use
So-
while there?
So while,
You're right.
while,
When test E.
oh,
Otherwise,
sorry. Yeah, thank you. When. Okay. So if I use while here, what happens?
infinite expansion.
Dr. Racket will be fairly quiet as it tries to infinitely expand out the while. So I want when here instead. So while true, printf high gives us all the highs. So the right thing to do is to make an actual test suite down here. But we're just being a little sloppy to move faster. Okay, and while false, it stops right away. Right? So I think everyone's with me, is that right? Moving too slowly? Just enjoying the easy ride for now? Okay. The last thing is task, and task is similar. I need a macro. Define syntax rule task, because I just want to supply the expressions that implement the task. And so that's going to be what we had before. Void, create a thread, where the thread's body is just those expressions. Okay. So now if I say task forever print high, then I can say task forever print by. And when I run this, it starts two threads, and so I get a bunch of i's and a bunch of highs, and they're interleaved some unspecified way. So with those three parts, we now can provide them, and we can use them in Fish 2, and we get the same thing that we had before. So what have we done? We've taken one step in transforming this raw sort of vanilla Racket code into the DSL that we're looking for. And this is the way we go about making a lot of languages. You start with either mentally or with an example like this, sort of the raw code, and think about how to get it closer and closer to the code that you wanted. What do you want to do next? What else is ugly here? What?
Put it other way.
Yeah, okay, right. How about instead of this class system stuff, define, duck, new sprite, etc., let's say that we just have sprite declarations. Right? So let's say we have defined sprite, duck. Right? And this removes another layer of things we don't need to know about. At first we wanted to hide away the thread part, right, and the let loop stuff. Now we want to hide away the new and the percent signs for class names. So I'm just going to have define sprite. The other thing I want to do here is, you remember in my original code, the tasks were associated with a particular sprite. And this is going to be interesting because in the end, we don't want to say send fish say score. We just want to say score. And so you need to know what sprite is relevant for that. So I'm going to group the tasks with the sprite as well. And variables also. Even though the variables are globally visible, I'm going to group them with the sprite, just to have some place to put them. So we're going to get that out of sprite.racket. So I'm going in pre-scratchy to sprite racket. And once again, we're going to have to write this. You can see there's a run plus there, which I didn't explain, but it'll become more clear after we do define sprite. So let's see, define syntax rule, define sprite. What should go there? What comes after a define sprite? Let's go look at what I had in mind. I've got a name, and then I've got things in square brackets that always have something and something else. Right. So let's see, let's close some of these old tabs. Okay, so I've got sprite and a name, and then I have a clause which has some sort of let's call it an init name, like the initialization, what sort of parameter we're passing in. And then it's got an expression for that. And I have any number of those. So I put ... after the group together. Okay. So that means not a repetition of the square bracket, but a repetition of this whole pattern. And what does this expand out to? That's defining name to be an instance of the sprite class. And then those init names, expers, those corresponded to the arguments. This is not going to be quite right, but I think this is close. Let's see, let's comment this out since we don't have run plus yet. If I do define sprite duck, then what? I could do image and duck image. Yeah, let's require images so we have duck image. Okay. Will this work? Some of you can probably read the red at the bottom. Okay, what's wrong with this? So new is not defined here. But it's going to be, it was defined formally in my fish thing. Should I make sure that new is bound over there? Or should I in other words, if I'm thinking of this as my use, then I import Racket class there. Oh, and we need sprite also. That comes from the runtime. Okay. So this now works, but this is in the wrong place, isn't it? Because what this is saying is that suggesting is that the use would need to have a new and a sprite percent and all of those things. And that's not the way we want to think about it. In fact, the reason this is working is because it's all in the same module right now. And really these belong up here. So this is saying the new gets its meaning not from the expansion context, but where we wrote it down.
So you're saying that the bottom is to reimagine a different module?
Yes, right. And it is a different module in the end here. But right now, think of all this as a different module, and that's why I moved the require up top, because it needs to be in this module for it to take effect. Right? In fact, if I just put it in the other module, it won't work. It has to be here. So that seems to work. I've got a duck sprite. How about if I have a task that is forever send the duck change size +1. Okay, the duck will get big fast that way. What happens here? Oh, no forever. Okay, that one really is going to be in the use, right? Forever is something that a user of the Scratchy language is supposed to know about. Oops, and duck. Typo there. Thanks. Duck is undefined. Okay. Maybe that was too complicated. Let's try just sleeping for a second and then sleeping for no time. And I'm going to comment that out. So we got one problem where I tried to use duck and it wasn't defined, but it was defined right there. And now I've got this going to sleep, right? What's going on here? Let's see, forever. Let's just sleep and not go forever. Okay. Now I got a different error message that said instantiate wasn't expecting a task argument. So we have a lot of problems here. We have using duck too early somehow, never getting our sprite back because, I don't know, it just seems to be going off somewhere. And then the most immediate problem, it turns out, is that task is not a valid argument here. Right? Task was not something that we originally passed to the sprite. We just made a top-level definition. So in fact, our defined sprite needs to be a little different. It needs to say any number of initial things, and then tasks are kind of special. Right? That we want to define them, but then we want just the task expression to be all by itself to create that separate task. But now I've got
Question.
Yeah.
Since we're doing expressions, that is, or arbitrary expressions following a definition, does that mean that within the body of a left we can only use one defined sprite?
Yeah. Well, so this is, in fact, this is not what. It's not a local definition here.
Well,
this define.
You know, if you wanted to make it local.
You could make it local, but we need it to be not local so that sprites can test where they hit each other, for example. And if you did want it to be local, it turns out in defined syntax rule there is nothing local to this syntax rule. What I'm going to do is actually put begin here so that I can have both of these things separate.
Doesn't task need to be a literal? The word task.
Yes, that's right. Task needs to be a literal. And then how many tasks should a sprite have? Well, it can have 1 or 0 or 2. So we've got more problems still. So in order to sort this out, it turns out we need to match different patterns, and defined syntax rule just isn't good enough for us. This gets us closer right here, in that we're expanding the defined sprite into define the name, like duck, followed by let the task get created. Right? That works well enough for this particular use. But it doesn't work if we have 0 tasks, and it doesn't work if we have multiple tasks. So what we need is to be able to match different possibilities. So instead of define syntax rule, I'm going to just say define syntax, and then syntax rules, plural. And then the reason these parentheses are here is so we can mention literal names that we want to match, like task, to clarify that this is not a variable that we're pattern matching, and it's not a pattern variable. Instead, I really just mean task. Actually, specifically, I mean the task that's exported by task. I don't actually. It's not just task. It's the binding task. Okay, so when someone uses task and they mean the same task that I mean, then I'm going to match it in this pattern. So that's one pattern that I will match. And let's see if I get the dots right. Okay. I also want to match the match when there are no tasks. So if I just do this, then the first case will match, and we won't keep looking if there is task at the end. Otherwise, we'll go on to the second case.
For the body of the first clause, task expert needs to also use task, or else it's not going to do it. Yeah, right there, you need to do task expert.
Okay, right. So here when I provide this I just want to say task forever, not task, and then open paren task forever. So. Okay, so here at this in this case, I want the same sort of pattern. And now you should wince a little bit because I just cut and pasted. Right. So at this point, we handle a task at the end or not a task at the end. What happens with two tasks? What if there are two things that match task at the end? Then the last one will get matched here, but the first one will still be treated like this. What we want to do really is just handle this first one and then look again at the end here. How could we do that? Well, we have this form, which I forgot to give a name, define sprite, that knows how to recognize a task at the end, so we can just reuse that again. So define sprite will expand to define sprite with all those other matches. And then this task here. So we saw before when I wrote a macro that used itself, that things would go bad. Is this one okay, or is this one going bad also? This one will be okay because you'll eventually run out of task matches at the end, in which case you'll fall through to the second kick pattern, and it'll finish. So let's see, my one example at the bottom still works. And it turns out we fixed two problems there. We fixed being able to have task, and also the fact that task gets wrapped around this expression. Right. So it comes back. I have a duck. There is a task that slept and then ended. We could change it like this. Right. So now we have a duck, and it turns out the duck is growing. If we do synduck get size. Yep, that's not what it's called apparently. I don't know. Get S? Maybe there isn't one. Let's go check the duck. Right, there's no way to get the size back out, so never mind. It's good to have documentation. I think it's probably growing. Let's see, we can move it. Move X. Send duck get X. All right, there we go. It's moved quite far, quite a ways. It's a fast duck. Okay, is everyone with me now? What did we do here? What was the point? We generalized define syntax rule to deal with multiple patterns. And you saw something that happens pretty often when you write these pattern-based macros, which is if you need to match sequences of things and pull it apart the same way you would with a recursive function, you can use a recursive macro too. So that gave us define sprite. Oh yeah, let's do one more thing. Let's see. Yeah, you know, this doesn't always work. It works right now. But there's a more subtle problem here, which is what if this task is just a thread? What if it gets started before I finish creating the duck? Could that possibly happen? Yes, it could possibly happen. How could I demonstrate it? I don't know. I could add in a... Well, if I do these in the other order, actually. If I do this in the other order, it might sometimes go wrong. Yes. Right, it says duck undefined, but in fact duck is defined. So what happens here is I just created the task before I defined the sprite. So maybe we should go back to my old code, but the thing is this isn't good enough either. Because you might define a duck and define a fish, and their tasks might refer to each other, and so you can't, what do you do? Right? The simplest thing to do here actually is to have some synchronization, and that's what run plus is about. So run plus is going to say we're going to start running it, so now let all the tasks go. So I'm going to make all the tasks wait until we're ready. So I'm using the Racket sync function to wait on some ready event. I'm going to define a ready semaphore. There's a variety of ways to synchronize these, but the simplest one is to make a semaphore. And then since I have lots of tasks that are going to look at the same thing, instead of posting the semaphore as many times as I have tasks, I will just have something that checks when the semaphore is posted without actually waiting on it. I mean, without actually decrementing the semaphore's value. So that's what ready is. And then run plus takes my list of sprites, and it runs as original the list of sprites, but then also says now we're ready to go. Okay, so there's some synchronization here that you really don't want to have to deal with when you're writing Scratchy programs, and now we put it in one place. It's not a macro thing, but it is a new piece of the language, the concept that you start going with tasks synchronized correctly.
We need to apply semaphore increment to ready sema.
Yeah, how does ready know about ready sema?
Yes, right, I forgot to connect them here. Thanks. Okay, and now even if I have these out of order, then it should be synchronized correctly. Of course, I haven't actually run it yet. Okay, let's start training, and you see the duck zoomed away. And we didn't run into any problems with synchronization because the task waited until the duck was defined. I'll put it back the other way just because I like it better that way. Okay, so that was define sprite. And what we've saved the Scratchy programmer from at this point is knowing about the class system, knowing the syntax of new. There's still some syntax here, but it's the syntax of define sprite, and in principle you go read the documentation for define sprite. Except we're waiting to get to the end language before we write the documentation. Okay, this whole thing should work now. It did not because I didn't save the file. Bad syntax. What went wrong?
There's a thing here with three things in the bracket.
Variable score. What are we supposed to do with variables? Those are not supposed to be passed on to the class sprite, right? What I meant was, and I just made this up, and I never told you in detail what I meant, right? So now we're deciding what it means. What I meant here is declare a variable whose name is score and whose value is this. Why did we get this scary bad syntax error message? What's wrong with this syntax? Well, we never said how to handle things with a name and two pieces, as someone said. What was your name? Sorry.
Jamie.
Jamie, as Jamie said. So what do we do with that? We just need another case. Let's say we're going to require variables to be after everything except tasks. So after we've picked off all the variables, and variable is a keyword here, so I put that up. It's a keyword in the sense I'm literally looking for variable. After we've picked off all the tasks from the end, we'll look for a variable at the end. That will need a variable name and an expression for the variable, in which case we are going to have not a task creation, but a variable definition. So now my macro has three kinds of patterns that it matches, but it's the same idea. And I can define any number of variables this way, as long as they come after everything else and before the tasks. Still bad syntax.
Is task saved?
No, so that's a good idea, but that wasn't it. I need to remove this stuff at the end. Let's not use it completely. Let's just comment it out.
The pattern matcher just matching in a variable, but then you don't no longer search for tasks.
Yeah, the clause for the case for tasks doesn't handle the
Oh, right. Okay, so we're still failing on this case because there is a task at the end, but we don't have three pieces here. At this point, I don't really care about the shape of the other clauses, though. And so maybe the way to think about this is I'm being too specific. It's define sprite's job to worry about the other clauses there. And that's still the case here as well. Okay, so what if we just didn't have 40 people here to figure it out? How would we do that instead? So let's say I'm back in the bad world. Right, this is the one that doesn't work. What do? I need a debugger of some sort. And it's called the macro stepper. So this is one of many things you rely on a lot to find out what's going on. And let's jump to the end, where it says bad syntax and step backwards. And it says bad syntax at this point. Okay. So it got this far. What do we see at this point? We see, so what it's showing me here is the expansion of the whole module. And we see that, in fact, duck expanded the right way. And this is the one that we got stuck on. So it's this exact thing somehow doesn't match our pattern. Right? So it's, in this case, it turns out to be the original expression didn't match the pattern in the first place. In other cases, when you use the macro stepper, you get this intermediate shape that didn't match the pattern. And then you can see how the intermediate shape evolved. Okay. So again, what I did here was use the macro stepper, go to the end, back up until I see something that was the input to the macro that didn't match. Or again, this whole thing didn't match. And then I go look at my task pattern and try to figure out why it didn't match. So then we did that, and we saw that let's see, redo, that's what I want. We saw that we should switch to just using clauses here. Okay. Let's try again. Let's see. Okay, I have to stop it because it did manage to start off some threads or something, and let's just go. Does anyone know why the run button didn't come back?
It's the macro stepper. You need to
The macro stepper will shut it down.
kill it.
Oh, okay, I tried break instead of kill. Okay. So now our game works again. So what was all that we just did? That was, we made define sprite, and the relatively new thing there was pattern matching with multiple cases, and in fact a recursive macro that relies on different cases matching different times around. Next. Okay. The next ugliest thing to me, is this. So it's got, I mean, lambda's not ugly generally, but in this context where I'm trying to give a simplified scratch, I don't want to have to write lambda here. I always just mean key down usually, so I want to assume that. And really I just want to write the dispatching part here. Up means this, down means this, right means this. Okay. So what I'm going to do is introduce a syntactic form key handler, right? A new language feature that lets me just write this simpler dispatch here. So let's write key handler. That's going to be in key.racket. So open up key.racket.
You always want to handle exactly those 7 keys?
No, let's just allow any symbolic name here and match it up. And well, you can see sometimes it turns out the way that key events are reported, sometimes it really is a symbol like down when you push the down arrow, and sometimes it's actually a character, a Racket character, which you would write #/+. And I want key handler to gloss over that too. Just write names down and it'll move them over to characters if it's needed for comparison. So do we know how to do that? Yeah, that part actually isn't anything new. I can write define syntax rule key handler, which has some keys and some expressions to go with that key, and then ... Do these ... dots work? This dot 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 says any number of expressions. And then this dot 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 says any number of those key, any number of expression groups. And I'm turning this into a lambda, which takes down and the key. And it checks that the key is down. And if so, then it does a dispatch on key. Oh, let's see, I've got a collision here. I meant for key to be a local variable. So let's call this given key. I don't mean the key that I pattern matched. And then it's each of those keys. I have to write more, but then I'm repeating for every key. Except I can't use case anymore, can I? Because I said I was going to allow symbols and characters. So let's change this to a kind, actually, that does some same key comparison on the key symbol as was written down and the given key. And then what goes over here? The expressions that go along with that particular key. And then we have the whole sequence of expressions. I still need, well, let's try it out. Key handler plus, and I'll print plus. Otherwise minus, and I'll print minus. Will this work? Matches the patterns and everything, but same key is undefined. Same key is supposed to take the key that we wanted and the given key, where the given key might be a symbol, so it might just be the symbol that we're looking for, or it might be a character. In which case we need to convert it, right? So it's a character and we convert it to a symbol with, well, we've got a character so we can make a string. And then once we have a string, we can convert it to a symbol. And now we can check it against key. So we want, either it matches immediately because they're both symbols, or we've got a character, we can convert it to a symbol and then try that. Does this mean my expansion works? Key handler gives me a procedure back. So that's as it's supposed to be. It's supposed to be a procedure that wants whether the key was pressed, and then a particular key. So that one works. And what if we had typed the letter A instead? I'm supposed to write it as a character, right? Nothing happens because there's no case that matches. Or if it was actually releasing the plus key, then there's no case. Let's add one to check, can we match letter A?
Like recap everything going on in this file. That whole
Yep.
line and
Yep, we're gonna go back over this. So what we have at the moment is we've got a key handler syntactic form that looks for a sequence of keys and expression sequence, any number of those, and then we're expanding out into this procedure. So that's why when we use key handler here, K is a procedure. And what it's doing is that procedure that we had before. It checks that the first argument is true, that it was a down key press, and then it's got a conditional to find which key we were given. And we had to write same key just to gloss over, characters versus symbols in our new language. Otherwise, when you match that case, then you evaluate those expressions. And I experimented with it down here to make sure it kind of works. What happens if I put a string here? And then I try it with A. Is that what we expected? The syntax of key handler was supposed to be that you write down a symbolic form, write down just A, not as a string. So we have if this is a kind of problem that might show up, we have a couple of choices. We can decide to handle strings and just make those work somehow. Or what we can say is, you're really not supposed to write anything but a symbol form here, right? An identifier kind of form. And so we might want to raise a syntax error when you misuse it. Right, so I'm going to go with the syntax object just because it's a new thing.
With the case, do we get an error for unrecognized keys?
No, the cond just falls through at the end.
I mean with the case, the way it was before.
Case we also just fell through in the original code. And when we get to the end, you'll see why that's kind of the natural thing, because you just specify the keys you want to handle. All right, so how would I change this to provide good error messages? I could do something like in here at runtime check that key is really a symbol. But then what if I wrote something like this? 1, 2, like that. If I try to do a runtime check, oh, I am putting a quote in front of it. Okay. I could do it at runtime and check that way. Since I'm putting a quote for anything I write there would be okay. But really, I would like to tell the programmer that it went wrong before they even run the program, right, in this case. And I can't really do that in a pattern matching macro, because as long as you match the pattern, you'll just get this expansion. And I don't, in this notation, have a way to say this thing must be an identifier. Now, a little bit later, we're going to look at a way to make it easy to say this must be an identifier. Okay. But as a more primitive thing, I'm going to show you something else, which is go back to using defined syntax. Let's keep this thing. I'm going to keep the old one commented out as just the pattern matching rule without. Okay, there it is. The pattern matching rule without any error reporting, right, without syntax errors. And then I'm going to make a new one here, which does do syntax errors, which uses defined syntax. At this time, instead of writing syntax rules, I'm going to write a compile time function. So when you write defined syntax, you can put syntax rules there, but what syntax rules does is make a function that does the pattern matching and the expansion for you. Okay? Or you can write just a raw lambda here, and that means you're writing your own function that runs at compile time, gets the syntax in, and gets to manipulate it however it wants. In particular, it can check to make sure that all of the key things, all of the keys in our pattern match are the same. So we want to write our own procedure, but we also want pattern matching. And so we're going to use syntax case, which is like syntax rules, except for a couple of things. And the first thing that's different, is we have to say explicitly what we're matching on, because syntax rules implicitly was a procedure that took its argument. And syntax case is not implicitly a procedure. It's just a pattern matching like case or con. And then STX, that was our input to our macro, right, our procedural macro, so that's what we're matching on. And then I can write key handler here, so that is now the pattern, just like we had it before with defined syntax rule. But instead of writing, we will write the expansion over here. But in syntax case, the other thing that's explicit is the fact that this is the expansion as opposed to some code to run at compile time. So I'd have to put it like this. Right? The hash tick means generate a syntax object. That is, generate a piece of expanded syntax. So again, we are writing key handler. Defined syntax means it's a compile time thing. It takes its argument stx, does syntax case for pattern matching, then generates the expansion here by putting hash quote in front of it. The advantage is now I can add some extra tests in between. And I can test to make sure that every key is actually an identifier. And how will I do that? Well, I just want to map some identifier tests, perhaps, over the list of keys. How do I get the list of keys? I can't just write key ... or list key ... And the problem is that this is the compile time code. It's not the expansion of the macro. So I'm writing regular code here instead of a template. I can write a template that corresponds to the list of keys. But that is a bit of syntax. It's still not a list of keys. So I need one more function, which is syntax to list, which takes a syntax form that has a list-like structure. You would write it with parentheses, and it has elements, and then pulls each of those syntactic elements into a new list. Okay, so I get a regular list back. Now I can do an nmap on identifier. And when I have this, then I try it, and it doesn't work right away. Lambda unbound identifier. How can that be? How can you be in a Racket module and not have lambda? My language is Racket base, which of course includes lambda, but that only gives me lambda at runtime. If I want to use lambda at compile time, I need to import it into compile time, and I do that with require for syntax Racket base. So now the for syntax part is what says import it, but not for running, import it for compiling, okay, which means I now have lambda at compile time. Okay, and this one is because I misspelled it. Identifier. And now I get an error that I actually wanted, which is telling me that key handler is bad syntax. It no longer matches. Okay. And the reason it doesn't match is because this and map produces false, and because it's right here in the syntax case, that means make sure that's true in order for the pattern to succeed.
Can you go over the part you have highlighted in gray there?
Yep.
What is open paren key ... close paren?
Okay, so this.
I mean, I know what it matches, but.
Right. So key is this pattern variable, so you know the syntax it would generate, right? And that syntax is, because I have this hash quote in front, it's just a value. It's a value that corresponds to the syntax of the matches of key repeated out. And then I'm using syntax list, which takes that one object that represents a sequence of things and turns it into a list of syntax objects, each of which was inside the original syntax object. So you had the syntax object. That was maybe ABC. And syntax list, syntax to list of this thing. Just abbreviating here, syntax to list of this syntax object gives me a list of individual syntax objects. Yeah, you can do it in the REPL. Okay, and then Dr. Racket prints out syntax in this way where you can go inspect all sorts of information about it, like where it came from. So if I just did ABC, you'd see I get one syntax object that has pieces inside of it, and syntax arrow list pulls the pieces out for me. Okay. So great question. Is it more clear now?
Yeah.
Okay. Great. Any other questions? This is where I start to think maybe it's news to some people here, so I'm hoping for more questions now. I'm actually not happy with the error message. The error message is bad syntax. Again, bad syntax. We could go use the macro debugger and so on, but in this case, key handler is supposed to be my new language form. I don't expect my end users to go use the macro debugger to find out why their syntax is bad. Right? Key handler should just give them a better error message. So what I really want to do is not just check that they're all identifiers, but if there's a particular one that's not an identifier, complain about that one and say it's not an identifier. So instead of doing an OR map or an AND map, I'm just going to do a regular map, or a for each, in fact, where I don't just check the identifier, but I take one of these keys, or really a syntax object corresponding to a key. And unless that's an identifier, then I'm going to complain. I'm going to raise a specific syntax error. So we'll fill in a little bit more here, but again, what's happening here is I'm checking For each element in this list, then, so key syntax corresponds to an element of the list produced from the syntax object. I check whether it's an identifier. If not, then I raise a syntax error. Now technically this is supposed to return a Boolean in this position in syntax case, so really I just need some block. I could use begin or let or something. Because now I'm not returning a Boolean, I'm raising an error or not. It would work the other way, but this is the way it should be. And then what goes in the ... Well, there should be an error message like not an identifier. Okay. But it's not enough to say that's not an identifier. Which identifier am I talking about? So for raise syntax error, I would want to supply the key syntax that I'm talking about. But also, if it just says not an identifier and it's in the middle of something where sometimes you don't realize you're inside a key identifier or a key, what's it called? Key handler form. So I'm also going to say, this is the form that you're in. You know, this is the overall form that we're complaining about, and this is the specific part. Okay. So this is just the raise syntax error protocol. You should give it an error message, the overall syntax that you're complaining about, you know, which syntactic form is doing the complaining, and then the particular piece that you're complaining about. And then you should put F here to say that you're doing what I just said, which is that the name that should complain is the third argument here. For historical reasons, you know, we would redo it now that we know how to do raise syntax error better, right? But instead we'll use something even better later. Okay, so now you can see the error message is not an identifier in 1.2. Dr. Racket can highlight it because the syntax object still has its source location stuck on it. You can see that the error message was from key handler. If we happen to import key handler with a different name in a different module, then the name here would adapt correctly because of the way raise syntax error works. Okay, so this was the intent of this part, to talk about writing compile time functions, to talk about some of the syntax object manipulation operators you have, like checking whether a syntax object corresponds to an identifier, taking a sequence and turning it into a list so you can map on it, raise syntax error so you can complain in a good way that works well with the programming environment. And still get the same sort of pattern matching and template that you get out of syntax rules. Any questions here? Okay, so I'm going to comment this out and go make sure my ducks work. Yep. Okay, we're back to shepherding fish, herding fish, schooling fish. What should we do next?
Go back to the file where you find forever for each loop.
For each loop?
And for each thing you have.
Okay.
How often have you written for each raise exception in your macros?
Very often, which is why we want the replacement that's a couple of steps away.
Okay.
This is pretty painful, right? It's a little bit tedious. In the general case, sometimes you have to do this, but there's a better way these days. So that was your question? Okay. Let me close up some of the old stuff. All right. So here we are at fish 4. What's the next thing to improve? I keep working my way down from the top. And the next thing that looks especially bad to me is send, right? Send duck move y10. I would really just like to say move y10. So why don't I just define a function move y that moves the duck 10? How would move y know what to move? This is kind of like a method. It needs to know from its context what it's supposed to do. But that's what we're going to do. We're going to make this work. So move y can't be just a regular function. Of course, it's got to be a syntactic form, a macro again. And the question is, how can move y as a macro know what target, what's the relevant target? And I think we see the same thing with with tasks, right? Tasks also, the advantage of putting them in the sprite is that I can just say touches, and you know I mean, is the fish touching the duck? Touches implicitly is the fish notion of touches. Okay. So that is going to come from, instead of using the old define sprite, we're actually going to define a replacement define sprite in the method class here. So if you're playing along, open the method Racket file. And you can see what I expect to export from this. It's define sprite. I'm going to re-export run plus because this method is replacing the old sprite file, right, for clients. And then these are all of the methods that I'm going to define. We can just take them one at a time first. So I'm going to have a say method. Let's use forward. So forward takes an argument x, and it's supposed to turn into a send to something forward the x. That's an expression. Define syntax rule. So the question is, how do we get the right ... And I say the right one is self. Okay, where self somehow should mean the class that you're inside of. But how do we set up self to be that? Self here, if you try to make the runtime analog, it's kind of like the current output port, right? When you call error, or the current error port, when you call error, you don't pass along the error port. It just gets it by using a parameter or something. So in fact, what we can use is called a syntax parameter. Self, and I'm just going to say false at the beginning, meaning if you try to use, which is going to have the effect of false is kind of like a bad macro. If you try to use self, it won't be able to expand, and so it'll complain. So that's fine for our purposes. To use define syntax parameter, I need to require the Racket stx param library. That gives me syntax parameters. So now I have a self that I can reference here. Let's see. It's complaining already, saying I can't use false because it doesn't know how to deal with false. Hash percent datum, what does that really mean? It means at compile time we haven't said what literals mean. So the bottom line is I need a for syntax Racket base. Turning it around, what that error message was really reminding us is that this false is a compile time expression. Right? And so I have to have compile time Racket in order to write it there. And then I haven't written all of these methods yet. So let's just kind of comment them out for now. Where is run supposed to come from? We'll do that later. Oh, forward is the one. Okay, I haven't done define sprite. I'm just trying to test out forward right now. So all we've done is write forward. So if I say forward 10, what happens? Send unbound identifier. What does this mean? Does that mean I need to import the class system at compile time? Right, so this is one thing that takes some practice, is getting used to whether you're looking at compile time code or runtime code. But you can always figure it out by looking at what's going on. It says define syntax rule. That means we've got a pattern and a template. The template is runtime code. So we need a send available at runtime. That makes sense. We need to call the methods at runtime. So I need Racket class as a regular import, not a compile time import. Okay, and now it's saying bad syntax self. This is the error message I predicted because self is just false right now. So let's suppose that during here, let's define duck to be a new sprite with an image that is the duck image. All right, so for this I need the images, and I also need the runtime for the example part here. And I want to say during this region of code here, self should correspond to duck. And here's how I do that. I do syntax parameterize. So just like making a parameter and using parameterize, if you know that part of the runtime language, then I'm doing syntax parameterize, redirect self to mean, so what is self going to be here? Can I just put duck here? It turns out I can't. So syntax parameterize is a compile time thing. And the right-hand sides over here are compile time expressions. So you can see the error message that I got, if I try this, is that duck is not defined, right? So duck is defined at runtime, but it's not defined at compile time or in the transformer environment. So the error message is saying, there's no duck at compile time. And yes, I know there is a duck at runtime, but it's not the same one. So that's not the one we're talking about. Okay. So how do I refer to duck? I need a syntax object that refers to duck. So I want to do that. Okay. That's not quite right, because when you bind syntax to just a syntax object, that's not the protocol for macros. So really I need a macro here that says when you use self, then you should replace it with duck. Okay. Except this is not a valid pattern in syntax rules. Syntax rules is limited where you have to have parentheses here. So let's just say whenever we use self, we put parentheses around it. And that's fine. Okay, and I don't need the hash quote here because that's implicit in syntax rules. Okay, so what this is saying is redefine, during the lexical body, inside the body of syntax parameterized, lexically. It's not a runtime thing, it's a compile time thing. In this gray region, whenever self is referenced, then if it has this pattern, just use duck in its place. Could I say syntax parameterize lambda, replace all lambdas with duck? No, because lambda is not a syntax parameter. Just like you can't say, make this variable x dynamically scoped in my whole program. That would break the rest of your program, right? For the same reason, you can't say syntax parameterize lambda, because lambda is not supposed to be a parameter. But when you introduce parameters with defined syntax parameter, then you can use syntax parameterize.
So you have two different cells here. One is the syntax parameter, and one is the piece of syntax that you're saying, open paren, self, close paren.
Yeah, this is the binding, and this is a use. And this is also a use. Right? So, because it's saying what parameter should we change? The one that's bound to self.
Could you have done something like syntax let? Let syntax?
So if I did let syntax, right, this would not work. If I just fix the parentheses. Okay, we still get the old error message here because this is a lexical binding that's really only applies here. Syntax parameterizes the dynamic binding analog. As long as self is declared as a kind of dynamic compile time variable.
So I think of parameters as if I'm not concerned about threads, continuations, etc. I can just do it with setbang. But there's no analog of setbang?
There's no analog of setbang here.
Right, okay.
But it is a dynamic extended design.
Yes.
It's a dynamic extend at compile time, right? So the thing is, you don't see self here, but the self emerges during expansion. And that's exactly what we wanted. On the other hand, if I put forward back out here, we're outside of the syntax parameterized, the self that emerges from expansion isn't captured and changed to the other. So syntax parameters are what you use when you need to get something like, when you need to be sensitive to your context in some way. So we made a step towards solving our problem here. Let's draw some lines at the moment. What we have is forward uses the syntax parameter self to know where it's sending the method to. Otherwise, it just changes something that looks like a function call or a syntactic form into a method call. And we have to do the same thing for move y, move x, and turn 2. Question?
I am still a little confused.
Okay.
The self that you have in gray, if you
Yeah.
replaced it with George, and then you replaced George down here in your syntax rules, in your tiny little syntax rules, this would still work?
No.
So they are sort of different. You just used self in two different senses.
Yeah, this one is using a pattern, sort of a pattern thing. So this pattern match, an attempt to match this pattern doesn't even fire until you match this identifier.
Oh.
Right? So I'd have to change this one to George. And now we're on our way, except that George is not a syntax parameter.
Right. So.
We'll get an error message saying George is not bound as a syntax parameter. Okay?
Yeah.
All right, let's do something easy for a moment, which is the same thing for all of these other identifiers. Right, they all have the same sort of shape. We have defined syntax rule, some sort of method, which takes some expressions, and they're just turned into a send of that same method name with all of those expressions, right? We want to do that for everything, so let's have a define syntax, define method, which takes the method name, and then we can just do define method, move y, define method, move x. Okay, that's getting a little tedious too. Let's do forward. You see where I'm going here, right? Even to set up my macros, I want macros. There's a kind of problem here though, right? What does dot 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 mean? It means take all the use matches of this pattern variable. That's not a pattern variable. Oh, this dot 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 is actually supposed to be for this defined syntax rule and not for this defined syntax rule. That's supposed to be rule. So how does dot 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 know which one to bind? Well, what we do is we use this funny little thing. If you put dot 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 right after an open paren, it's kind of a neat, it's a hack. We're just reusing dot 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 to mean escape dot dot dot. So it sort of cancels the meaning of these dot dots for that syntax rule. So these dot dot dots are ignored by this syntax rule. They're preserved in the expansion. This kind of stuff happens when you write macro defining macros. So this much will work. Right, so forward now is defined via define method, but even this is getting tedious. Really, I just like to say define methods, define them all at one time. Can we do that? Well, that's just a dot 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 after this method. And yeah, that's fine. We just repeat this whole thing for every method. Okay, so this dot 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 cancels these dot dot dots for the outer defined syntax, but this one is still in effect. So we duplicate this whole thing for every method. I did not set out to make this example like this. It's just what fell out when I tried to implement it. And so that kind of thing really happens. And it's nice when it happens and it just works once you get used to it. And so we've fairly compactly now implemented all these methods. I could even put the provide in here so I don't have to repeat it up there. Yeah, let's do that. Okay. After I define all those things, I want to provide them all. That way I only have to write it in one place.
The macro name should change.
What?
The macro name is to define methods.
Oh, define methods. Okay. So what did we learn here? Mostly syntax parameterized was what I was trying to get to. Notion of capturing your context, but we also saw how pattern matching and macro generating macros and the pattern matching system is set up to do that reasonably well. Great. All great scheme stuff that we inherited there in terms of pattern matching. So that's all great. We still haven't done define, sprite, and run. The run plus, I really do just want to re-export the original one. So I need to import it from, where was that? Sprite. Okay. And now, do I want to just re-export define sprite? Why did I say I want to redefine sprite? So in my example down here, I used a syntax parameterize to say that self is duck. Right? But in our fish program, the programmer is not going to say, I mean duck. Where does that come from? It comes from the fact that we're in define sprite. So that's why I'm redefining define sprite. So what define sprite needs to do you've got define sprite, some name, and some clauses. And we want to do a syntax parameterize to say that self should be redirected to whatever that name was. And then in there I want to define the sprite, but I want the old define sprite. So I just like to use the old define sprite inside the syntax parameterize. So I'm going to call the old one define sprite original, the same name and the same clauses as before. Yes?
So I guess it's just a design question. Why are you redefining define sprite here?
I could go back and change the other one somehow and rearrange my modules, but I've set it up so I can keep reusing the code and move forward. And because it's illustrative, it illustrates a point, which is very often you want to redefine a name, and so how do you juggle the names? So here's how we juggle the names.
You were designing this to be read by other people. It might get confusing that there's two different define sprites.
Yeah, so how many lambdas are there? There's a bunch, it turns out. So you do have to know what language you're using in general. So I'm going to use rename n here to rename define sprite within this module to define sprite orig. And then I can just export the one I defined here, re-export run. Let's see. I meant to write define syntax rule here. Anything else? Okay, let me comment this out for a minute. Let's try define sprite on duck, which is going to have this image. And in principle, that should be all we need. And now we have a catch. It says, no expression after a sequence of internal definitions in begin define sprite duck. Okay. So you could use the macro stepper to find out what's going on here. But you'll find that this expands to this, and it's calling this a local definition, which is not what we wanted. So it turns out that syntax parameterize is an expression form. It doesn't splice into its context. What we really want is a splicing syntax parameterize. So we use splicing syntax parameterize, right, which is in a different library. It's in Racket splice. Splicing. Okay. Now it works okay. And so we've got a duck. And, well, we didn't use anything interesting, did we? Let's have the task that says forever forward 1. Right? And that should move the duck forward 1. I think I'm going to need forever, right? Which comes from task.racket. Okay, so we've got our duck, and if all is well, then when we send the duck get x, the duck was pointed. Hey, why didn't our duck move? Oh, that's right. I have to do run plus now. Remember, I synchronize my task until I do run plus. So we'll just actually watch the duck zoom away. Okay. So the point here of that little experiment was that, yes, in fact, this forward is going to the right place now, right, using our revised define sprite. Okay, so an hour and a half in, and this is what our program looks like. It's starting to look better, right? But now if I started from the top again and look at everything that's going on, that kind of bugs me, that I write all of those requires at the top. So I could put them all in one module. But another thing that bothers me is I have to remember to put run plus at the end. And as you've just seen 30 seconds ago, I have trouble remembering that. So what I would really like to do is have something more streamlined where I say, this is a scratchy program, just define the sprites and let it go. Right? So that brings us to our next step, I think. No. Okay. That will bring us to this step. Sorry, wrong order. What I did here is I decided to change it from the square brackets to keywords.
I can read text just fine, but I can't read the file name.
Right. Okay. So we're up to fish 6 now.
Or fish 6.
Yeah, and I gave a great introduction to fish 7. So fish 6 was changing this to keyword form, and the reason I do this you'll see in the end, but it makes it easier for me to write key as separate things, which if you remember where we're going, that's closer to on left key, on right key, and so on. So I've just sort of changed the syntax in a way here, and where that's supposed to come from is keyword sprite. So I'm going to define sprite again, but this time using keywords. And this is going to be too much to type, at least at this point. So I'm going to go, let's open keyword sprite, which is here. But then I'm going to completely cheat and go get the one that I wrote before and explain that instead. Okay.
You just opened the same thing.
Just opened the same thing? Yes, I did. Scratchy. Keyword sprite. Okay, so this goes back to Matthias's question. You can see I'm using define syntax, define sprite, lambda stx. I'm just using the shorthand, the usual shorthand here. And now I'm not using syntax rules because I'm writing a compile time function. This is scratchy keyword sprite now is where I copied this out. This time I'm using syntax parse, which is an improved version that's like syntax case but gives me a much more expressive language for writing down patterns. Okay? And gives me a lot of error support with it. Because I'm sort of trying, because the underlying things still bleed through in various ways. For example, the hash quote here. So syntax case is a smaller step from syntax rules. Right? And now we're enriching the pattern language a lot.
Syntax probably this is on tutorial that Verizon volunteered to do next year. So
Yeah, that's right. So come back next year to find out details here. But I will go over this slightly, which is to say it's a similar sort of pattern. Underscore in all the pattern languages so far means don't care. Right? Then you see I don't have just name, but I have name : ID. So unlike all my define sprites before, if I say define sprite 7, this will give me an error because 7 is not an identifier. Let's try that. So here if I say define sprite 7, then I get an error message that says expected identifier, and I didn't have to write that error message myself. All I had to do was annotate this pattern and say, I want an identifier. So everywhere where you see the colons here, those are called syntax classes. And ones like identifier and expr, those are predefined, and you can define your own as well. Yes?
I guess I'd like to rephrase my question. Just the fact that you used syntax case before syntax parse in this tutorial suggests that people defining their own languages should be the same.
You should probably move to syntax parse a little faster, right? Unless you're defining something really simple. You probably didn't even consider someone writing define sprite 7, right? And so our original syntax case version didn't give you a good error message. But when you write down things in syntax parse, you naturally think of this, and then you get a good error message out of it. Yeah, so move over quickly. Or skip syntax case and go to syntax parse. So or says, you can see or and this ... is after this or. So it says any number of repetitions of this thing. right? So tilde or here is not a pattern variable. It's a constructor of patterns in the pattern language. And once here is saying, you know, because it's under dot, 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 any of these things can happen multiple times, but make sure that this one only happens once. That's what tilde once means. And then tilde sequence means I'm going to write some things here because I want to group them together because they are repeated together. But when I actually use it, I don't put parentheses around it. That is, I don't put parentheses around the keyword and the expression. So that's what sequence does. It's kind of like a splice. And so it says this keyword and then any image expression, anything matching the expression syntax does. This one, in contrast, says X followed by an expression. That's optional. So once means it has to happen exactly once. So you do have to specify an image first, right? You don't have to specify an X. And if you don't specify it, well, we say that the X expression by default is just the expression 0. Okay. So optional followed by a pattern. This keyword is actually part of the syntax of optional, right? This is saying the default for this optional pattern. Okay, so there's both layers happening here inside the pattern language. Right? And this is the same XXPR as this one, because it's saying if you don't ever see one of these, then bind it to 0. Optional means 0 or 1 times it can show up. And these don't have optional on them because they can happen any number of times. You can have any number of keys, any number of tasks, any number of variables. And this is a great improvement over my earlier syntax in that you don't have to put tasks and variables and keys in any particular order. Right? The or here with the dot, dot, dot means it can be in any order.
Just one bit of foreshadowing. If defaults looks visual to write to you, then I'm going to show you later how to get rid of it.
Oh, there's a better way to write it? Okay. Good. What is it? You want to just tell me? Or are you telling us later?
Use template.
Okay. Oh, yes, okay.
I will grab your example.
Okay, great. So you're telling us later today how to do this better. Okay, good. And there we go. The template part looks just the same. It was all of the interesting part here is in the pattern matching, except that Ryan's going to tell you more about interesting templates later. Okay, so you get the idea. I know I haven't explained this well enough. Go read the documentation or see Ryan's forthcoming tutorial on syntax parse. And that's all this does. It defines sprite in terms of define sprite original, which this time was the one from method. So I just played the same renaming trick to move it along. And that got us here. Okay, so this one works. If I've saved everything right. No, I haven't. Okay, so just to make sure I was on track there. So now, remember that setup? Remember I said I forget to write run plus at the end, and I don't want to write this now even larger pile of requires. So that's where we get to fish 7. No, yes, fish 7. Okay. I see, I just ran fish 5 again. Well, we'll go back and check if fish 6 works later. So here's fish 7, and now you see at the top, you can see it's going to take me a while to get this really completely clean. Right? So right now it says hashlang sx. That means I'm still using parentheses. Right? So what we wrote before every time was hashlang racket something, which says parentheses and lambda and define and all that other stuff. Right? Hashlang sx just means using parentheses. And then sx expects me to write something after it, which tells me what is supplying all of the bindings. Right? So sx is just s expressions, just the parentheses. Almost scratchy is supplying all of the bindings, like define sprite and move y. So if we go look at almost scratchy, okay, we see that it has all that same pile of requires that we had before, and it's mostly just re-exporting all of those things. Okay? But also you see hash % module begin. Okay? And the hash % module begin is because nobody wrote hash % module begin here, right? You generally should not write hash % module begin. But when you wrote a module, you wrote it implicitly, because that is the implicit form for the whole body of a module. And the reason I want to redefine that is I want to see that I've defined the duck sprite and the fish sprite and the aquarium sprite and automatically put the run plus at the end. So that's what I want to do with Almost Scratchy. I want to export module begin, except this is a module, right? So is there already a module begin? Yes. So in this case, I'm going to rename on output because I'm making a new module begin that doesn't apply to this module, but to modules that import from this one. Okay. So define syntax rule module begin with, all right, what's in the top of my module? It's all going to be just defined sprites. So I have any number of defined sprites, each with its ID and the rest of the defined sprite.
No hash map. No hash map. No hash percent.
No, oh, right. Right, I'm defining module begin, not hash percent module begin. And what do I want that to expand to? Well, I want it to expand to the regular module begin, the one that comes into this module, that is the regular one. All of those defined sprites. Sorry, I don't know why I put that dot there. Right, that repetition, and then I want the run plus automatically at the end with all the IDs. Okay, so what this is saying is, when you write a module, that top level of the module must be a sequence of defined sprites. The only thing you can write is defined sprite now, at the top. And we're going to keep all of those, but also at the end, add this run plus call. And this is not going to be, let's see. Let's see. Collection not found. Do I have a dot 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 somewhere still?
Some keyword sprite.
Oh. Right. In fact, I never copied it over. Thank you. That was all the code that we wanted to use. Okay. So now it's happy. And we go back to fish 7. And now it should match up. Everything in here is defined sprite. Right? What?
What was the last change you made?
So I just fixed up keyword sprite, which I had not done before. And then that was it. But my program still doesn't work. It says it doesn't know what to do with a number like 100. That's because Almost Scratchy really has complete control over the language. I exported images, task, key, keyword sprite. I didn't export any of Racket, which would include handling of numbers. So for simplicity, I'm just going to just provide all of Racket, although in principle, all of Racket base at least. In principle, I have more control here, and I can use that control to withhold things, which might be a good idea in the long run for this language, but I'll just do this. I can't write it quite like that because Racket base provides hash percent module begin, so I have to not reprovide that module begin. Now I think fish 7 will work. Okay, sort of, except the aquarium is on top of the fish now. And that's an ordering thing. I wanted to write duck, fish, aquarium, front to back, but run takes them back to front. You may not have noticed I reversed the order before, so that's an easy fix. I just reverse the order before I pass it to run. What if I wanted to reverse the order at compile time of these identifiers? Then I would need to write a general compile time function, and I couldn't use define syntax rule here. So I'll just do it at runtime, which is just fine for this program. All right, and I think I remember why it's getting slow. I have compilation turned off. So that was fish 7. The next ugly thing is I have ignore that fix-up. So the next, what if I did in my task a set bang on duck to be 8? So I've decided not to withhold parts of Racket. I gave you full set bang. And so you could use set bang on a variable like you're supposed to, or you can use it on a duck. So what could we do? We can replace set bang with our own set bang. But how should it know when it's allowed to change when it's giving a variable or not? That is another thing that's determined by the context, right? So I need, in some way, to communicate the context that score is a variable. So the way I'm going to do that is with Scratchy. So now I'm moving to Scratchy, which is why almost Scratchy was almost Scratchy, right? Because I just wanted to fix up this set bang thing. And this set bang needs to somehow say, define syntax is going to be a compile time check. This check set bang, I've got a syntax object. It's going to have the form set bang ID right hand side. And I just need to make sure that this ID is a variable somehow. So I need to make sure that that piece of syntax refers to a variable that I've declared in Scratchy. And if so, I'm happy. I just convert it to the regular set bang. This is actually check set bang. Convert it to the regular set bang. Otherwise, I will complain. I will say not a variable name in that syntax object, specifically the identifier. Yeah. The only thing that remains is how do I implement this test variable? Okay. Well, to do that, I need to change the way that variables are defined. Because right now, there's just not a way. If we go back into, it's not method, it's define sprite. Right. So here's where we're defining variables. Right? Back in our original define sprite. Okay. What I need to do here is say define variable somehow. I need to make explicit that this identifier is a variable and communicate that information over. When does recording the fact that it's a variable happen? It's a compile time thing, right? So I'm going to need a variable module that has a compile time notion of variables. Right? And gives me define variable. So define variable is just syntax. Define variable, some ID, some right-hand side. It mostly expands to just a definition of that, but it also needs to record somehow that that identifier is a variable. What we're actually going to do is say define syntax ID. It's a variable. And that, so this is defining ID at compile time now. It's not a runtime identifier. The runtime thing that we actually define, I'm just making up a name, gen ID. And then at compile time, I'm binding ID to something that says it is a variable and its runtime component is this generated identifier. So I have two definitions. I need to put them together. And then this can just be a compile time constructor of a record that also acts like a macro. So it changes every gen ID to just ID. So how do I make a compile time structure? It wants to be something like variable, struct variable with the runtime ID inside of it. But if I just write that, that's a runtime thing. So to make it compile time, I just do begin for syntax. So that's a compile time declaration of the variable structure. And you can see that I exported variable question mark for syntax, because variable question mark is used at compile time to check whether something's a variable. And so this is all consistent now. Define variable is not for syntax. It is a compile time thing, but it's used in runtime code to bridge between the two. So we're almost there. The only thing is I need this to behave like a macro. So it's got to act like a procedure. So I make this structure act like a procedure. And I tell it, when you see a set bang, yeah, etc. What's the easiest way to do this? You know what? I don't.
You already have to.
I have variable, What I need is for this identifier to act like a macro to expand to gen ID.
Yeah, sorry.
Yeah. And every time I do this, I find it more tedious than it seems like it should be. We need a better library to do that. So I'm just going to go copy this since we're really short on time now. Here, see, that's the code I didn't want to write. There should be a short way to do this. So this is saying this structure has the property setBang transformer, which is a very fancy procedure. It's a procedure that expects to be called sometimes when you use it in a setBang expression as well. Right? So this was more than I wanted to talk about, but in addition to regular macros, we have setBang transformers, which are macros that work even in the setBang left-hand side. And so it's matching in a setBang left-hand side, or when you're using it like a function, after parentheses, or when you're using it all by itself. And in all those cases, we just return the ID that we have. Right. That's what this is doing, and there really should just be some way of saying, a redirecting macro. Right. So read that as struct variable, which has the property that it behaves like a redirecting macro, redirecting to this identifier, which we put there when we constructed a particular variable instrument. Now we have the variable predicate, which is exactly what we wanted in our new Scratchy. In fact, I was already requiring variable, so I can use variable for syntax. So that check setBang should work now.
One quick question. If you had a runtime error, would it be reported in terms of gen ID rather than ID?
Yes. So we would want to make sure in various ways that you would fix that. In this case, I've arranged for the variables to be defined before you can try to use them, so you won't see it. It will always be, right? It will always be there. Okay, so now this one should work. And, well, it should have worked already before. What we were trying to do was prevent something. Yeah, I got this kind of wrong. No, what? All right, we get to debug again. What was the error? There can be only one expression in the definitions window. Yes. Had some leftover there. Okay. I wanted S expression. Thank you. Okay, so it says score is not a variable. That's unfortunate, because we did define it as a variable. Let's see. Define syntax ID variable. Scratchy. If variable ID. Uh-oh. What?
Gen ID is here, right?
No, I don't think so.
Identifier is not a variable.
Oh, yeah, right. Thank you. Yeah, this is not right. I needed one more piece. This is just the identifier. It's a syntax object. It's not a variable structure. What I really meant is the compile time value of this thing. And to get the compile time value of it, it's syntax local value. And this lambda f, that's the failure thunk, so it's going to return false if it can't get a compile time value for that identifier. Thanks, Ryan. Did everyone catch that? One more time, ID, that's an identifier. It's not a variable. But its compile time value, that's what we want to know whether it's a variable or not. That's why we go back and run the fish program every time.
Did you change something in fish 8 itself?
Yeah, sorry, the fish 8 that I gave you, I rearranged things. At the top, it should say #lang s expression scratchy. Okay, so now it works again, but if I uncomment this, then it complains about duck not being a variable this time. Right? And that was a compile time error. Okay, the very last thing that we're going to get to is taking care of the #e's here. So that's the last most ugly thing here. Holdover from Racket. I just want to write 0.1 to mean exactly 10% here. And the way I do that is now I'm changing the #lang line. It doesn't just say parentheses. It says reader, which says I'm going to implement the reader from the beginning if I want to, from scratch. And exact is the module that implements the reader. So by the reader, I mean the parenthesis matching up the part that feeds into the macro expander. This is going to be easier than it looks, but I'll still just go grab it. Okay, exact. Okay, I'm going to go ahead. I'm going to copy it over so I don't forget. So what this is saying is, well, it says I'm using this language here, syntax module reader. So I'm using a domain-specific language in order to implement my domain-specific language, right? Which is the obvious thing to do. This domain-specific language lets me specify things about a language, such as the exact language. And it says, this option says, I will give you the input for it, and you get to find out what is the module level language. That is, what provides the bindings. And the exact language doesn't know. It reads from the input program to find out where to get the bindings. And that's why fish 9 has exact and then scratchy.racket. So that #lang reads this scratchy.racket to decide where to get the bindings. And then it's got read and read syntax, which do basically the same thing, just depending on whether you want source location and so on. And the key thing here is I'm using the regular Racket reader, read or read syntax, but I'm parameterizing it. It turns out the Racket reader already knows how to let you say that numbers should be read as exact if you just set this parameter. And so I'm setting that parameter using Parametrize. It's a runtime thing at the runtime of the reader, right? Saying that don't treat it as an exact, so it gets treated as exact. So that's why fish 9 here is the same sort of program as fish 8, even though I took away the #e's. Make sure. There we go. And if I increase the duck, you see how that's growing by exactly 10%? And shrinking down by exactly 10%? Well, it gets to the same place at least, which is nice. All right. I've got 2 minutes. All I have to do now is write a parser. Because, remember, we're trying to get to fish.racket. So what does it say? It says #lang scratchy. How does that even mean something? It's because I installed the Scratchy collection. Right? And so it says, go look in the Scratchy collection go look for the main module of that collection. Main module. And see if it has a reader submodule. And look, how about that? It has a reader submodule. So when we did #lang s expression, that sort of went and found a module that did parenthesis reading. In this case, it's going here. It has a reader submodule, and it says, well, just reprovide everything from reader. So let's go look at reader. Reader has, it defines read syntax and read. And it defines read syntax as use this other parser, which is in yet another file, which knows how to deal with the lines and the word move to x or move x and so on, right? So That parser is responsible for taking characters to syntax objects. And then I just package that up as a module using the Scratchy language. So let's go look at the parser. I don't think I could have typed this all in 1 minute. Right? This is your typical Lex and Yak style parser, where I define a bunch of tokens. These are all the keywords in my language. This is, the BNF. It's actually not using Yak, it's using an early parser that's tucked away in the Algol 60 language right now, but we'll probably move that over at some point when I clean up the error reporting. But it's what you expect, right? Y with white space, and the keyword is with white space expression. Build up a list that has the keyword Y and then $5 in Yak form means whatever you parse that expression out of. So those parses, the lexer and parser, are put together here by this parse function. And that's what we're using here. And you see one more thing. There's a getInfo. GetInfo, you can ask it for how should Dr. Racket color the syntax. And it says use color lexer, which uses that same lexer that we had for the parser. But then when it gets different kinds of tokens, it says color open and close as parentheses, color a number as a constant, color an ID as a symbol, and so on. And that's why, when we look at fish, that Dr. Racket is able to color it in a nice way. And hash is not a valid character in this language anywhere in the grammar, so it can color it as an error and let me know I've mistyped. Or if I try to use fractions, which are not, well, no, I can use fractions because that's a division operator in this language. Okay. But I can't use exponentiation so far. It's not defined. And you can see I pasted the duck directly in. That requires a little bit of lexer magic and parser magic, but it's just an extra kind of character, a special character in those parsers. And the rest falls through. And, well, 1 minute over. Now you can all go chase fish with ducks. Thanks. And obviously I'm here all day if you have more questions. Do we want to take any questions now?
What lunch has arrived, so why don't we let Matthew answer questions while we let him get some lunch. And then after lunch at 1:30 we're going to have some exciting talks about cool things that people are doing in Racket.
No.